Hello! Yes! And welcome to our Objective 5.3 notes on long division of polynomials. Objective 5.3 says I can divide polynomials using long division, and that, my friends, is what we are going to do today. There are two methods to dividing long division. To dividing polynomials. One is long division, that's what we're going to do today. And the other is synthetic division, and that's going to be Objective 5.4. Synthetic division has a few stipulations, a few conditions in which it can be used. Long division, however, works every time. So that's going to be our focus of today and kind of our bread and butter here for a bit. So long division of polynomials is just like long division with numbers. So let's take a moment to reflect. So remember, if I wanted to divide 1738 by 11, I would first set it up here, right? So I have my divisor and my dividend in place. I have 11, and I say, how many times does 11 go into 17? Well, one time. So 1 times 11 is 11. I subtract. I get 6, and I bring down the 3. How many times does 11 go into 63? 5 times. 5 times 11 is 55. I subtract, bring down the 8. How many times does 11 go into 88? 8 times. And we see here then that 158 and 11 are both factors of 1738. Now, that won't always be the case where it works out nice and neat, not with numbers and definitely not with polynomials. So let's try one where maybe that doesn't occur. 15 and 1985. How many times does 15 go into 1985? Well, 15 goes into 19 one time. Do my math. 15, I can subtract. 19 minus 15 is 4. Bring down the 8. 15 goes into 48 3 times. 3 times 15 is 45. I subtract a 3. Bring down the 5. 15 goes into 35 twice. I multiply and I'd get 30. And then I get this remainder of 5, right? I have nothing else to bring down. This would be my remainder. And in this case, what we're going to do is we're going to make a fraction. So 5 over 15, so that would become 1 over 3 when I simplify. And that's the process. Hopefully we're feeling pretty comfortable with long division. If not, might need to give our 4th grade teacher a call. Or we can work on that together. So we're going to write our remainders as fractions, where the numerator is the divisor. Where the numerator is the remainder, and the denominator is the divisor, what's doing the dividing. So that's how we got the 5 over 15 up here. 5 was our remainder, and 15 was our divisor. If the quotient does not have a remainder, then the divisor is a factor of the dividend, of course. And in order to divide polynomials, the polynomials must be in standard form, our good friend. That's why we've been working on it so much so far. All right, so let's give it a shot here with some polynomials. Let's start with letter A here. So we have this polynomial we're going to divide by 5k plus 1. So we'll put 5k plus 1 on the outside here. And then my dividend, 5k to the 4th, minus 39k to the 3rd, minus 23k squared, plus 37k plus 14. All right. So let's do some math. So when I'm doing this, I only care about the first terms. I don't worry about the plus 1. I don't worry about anything like that. So I say 5k times what gives me 5k to the 4th? That would be k to the 3rd. And then I'm going to subtract, and then I'm going to multiply, so 5k to the 4th, and then k to the 3rd plus 1 would be, 1k to the 3rd, and then I'm going to subtract this value. So if we do this right, our first term should always become 0, and then our second term is going to give us our new. So negative 39k minus k to the 3rd was going to give me negative 40k to the 3rd, and we bring down negative 23k squared. All right, so now 5k times what gives me negative 40k to the 3rd? Well, that would be negative 8k squared. So that would, negative 8k squared times 5k is negative 40k to the 3rd. Negative 8k squared times 1 is negative 8k squared. And I'm going to subtract these. Now let's see here. Negative 23k squared minus negative 8k squared. So that subtracting a negative would turn into addition. So this would become negative 15k squared. And we bring down positive 37k. So 5k times what? Hello. I'm not sure how that happened. I don't even know what that is. There we go. 5k times what gives me negative 15k squared. So that would be negative 3k. When I multiply that, give me negative 15k squared. Negative 3k times 1 would be negative 3k. And we're going to subtract that. Obviously, be careful with our subtracting a negative here. This will give me 40k. Bring down our positive 14. And then 5k times what gives me 40k? 8. And then I would get 40k plus 8. Subtract. And when I do that, I'm left with 6. So 6 here represents my remainder. So my solution, my quotient here, I would take this 6 and I would say plus my remainder divided by my divisor, 5k plus 1. And that would be my solution. Let's see if we can't get that k to the third included. This would be my quotient here. There we go. Let's try another example. Now notice here, our standard form, we are in standard form, and that's great. But we are not with all of our terms. So what I'm going to do here, we are missing our linear term. So I'm going to say plus 0x, right? I'm going to fill it in that gap, and then we have our plus 18. And that way we have third degree, second degree, first degree, and our constant. And then we repeat, it's the same process that we just did. So we'd say 2x times what gives me 16x to the third? Well, that would be 8x squared. When I multiply, I'd get 16x to the third plus 16x squared, and I'd subtract. You get 0. 6x squared minus 16x squared would give me negative 10x squared, bring down the 0x. So 2x times what gives me negative 10x squared? Negative 5x. Negative 5x times 2x is negative 10x squared. Negative 5x times 2 is negative 10x. So I'm going to subtract. It'll give me 0, and 0 minus negative 10 would become positive 10x. Bring down the plus 18. 2x times what gives me 10x? 2x times 5. 5 times 2x is 10x. 5 times 2 is 10. Subtract. And that leaves me with 8. So that would be my remainder. My quotient here, 8x squared minus 5x plus 5 plus 8 over 2x minus 2. And there we have it, folks. Long division with polynomials. Like I said, it's that same process of long division with numbers, just some variables thrown in. It's pretty fun. Go ahead and get started on those sample problems or practice problems, and then we'll check in with those here in a bit, all right? This is Mr. Carter signing off. I'll see you next time.